Hello students, welcome to Naran PU College online classes. So in the last video we have discussed about the shapes of the molecule based upon bond base, and first I have given one table that is without lone pair, and the second one is the central atom is having with lone pair, bond pair and lone pair, and first one is only the bond pair, there are no lone pairs. Clear? So that we have already discussed, and here the same second table continuation it is same, that is here what is the shape, why the shape is changes. Actually if I take here, if lone pair comes, then automatically the shape of the molecule changes from the regular shape to different shape. Clear? Suppose if I say here there is no lone pair, just all are bond pairs only, just assume here AB3. Clear? Means what it is? A and B and B and here B. Then what is the shape? Regular shape it is trigonal planar. But what it is, due to presence of one lone pair, and it is changes trigonal planar, it changes to what is bend shape. Why it changes? Then we have to see the reasons here. Clear? So when lone pair is present on the central atom of a molecule, then it changes it distorts the shape of the molecule, and how it will be that I will discuss here. Clear? See, I have already discussed here AB2. A represents what is the central atom, and B represents the surrounding atoms, and E represents the lone pairs. Clear? I already mentioned. So now, if two bond pairs and one lone pair, I have given the shape of the molecule is a bent shape. What is the example I have given there? You see, one example I have given, one of the example is SO2 and another one is the O3. I have taken here SO3 is a example. Clear? So now, due to this lone pair, why the shape changes? Clear? See now, here what it is there, it is a lone pair, and these are what it is now, bond pairs are there here. These are which one now? This is a lone pair, and these are which one? Bond pair, and here it is a bond pair. Clear? Bonds are there. You know that the repulsions order lone pair repulsion is repulsion is greater than the lone pair bond pair repulsion, and it is further greater than the bond pair repulsions. Clear? This I have already given in the last class. Clear? So if you see here, we have only one lone pair, so that's why lone pair repulsions we need not to consider. But here what happened, you see, here lone pair, and here which electrons are there? Bond pair electrons are there here. These are bond pair electrons. Then what will happen? There will be a repulsion between the lone pair and bond pair. Got my point here? There will be a repulsion between lone pair and bond pair. Here also lone pair and bond pair. Lone pair bond pair repulsions are greater than the bond pair repulsions. Then what will happen here? The angle will reduces. Clear? And that is the reason why these molecules are having which exact shape. Trigonal planar shape should acquire this molecule, but due to that lone pair, which one? Bent shape. So how it will be means, see now. So in this one, what happened? There is a S double bond O, and here also what is S double bond O, and here lone pair. Clear? And there will be a repulsions between which one? Here bond electrons I am writing, bond pair electrons, lone pair electrons. And there will be a repulsions between these two, and also here repulsions between these two, bond pairs and lone pair. Then what will happen? And due to this repulsion, to avoid that repulsions, you know, these two bonds will come close. Why? Because here which repulsions will be formed? Bond pair and bond pair repulsions here between this, and here bond pair lone pair, here also bond pair lone pair. But bond pair repulsions are less than lone pair bond pair, so that's why 2 and decreases the, or to minimize the lone pair bond pair repulsions, these two bonds will come close. Why? Because bond pair repulsions are less compared to lone pair and bond pair, so they are come close. Then automatically angle changes from 120 degrees to 119.5 degrees. Actually, regular trigonal planar means what is the angle should be 120, but here the angle is how much over here? The angle here is 119.5 degree. That is the reason why this molecule acquires here what is the bed shape. Okay, so that is the reason, because I have written lone pair bond pair repulsions are much more compared to the bond pair repulsions, so the angle is reduced from the 120 to which one? 119.5. If 120 angle is there, then you know it is a trigonal planar, but angle changes from 120, so that's why it will have some different shape. What is that different shape? Bed shape. Clear, my guys? That is the one place. And second one we have taken AB3E means how many bond pairs are there? 3 bond pairs, 3 bonds here, 3 bond pairs. E means represents 1 lone pair. So this is the shape. Clear? You know that if there are no lone pairs, this is also bond pair. Then what should be the formula for that molecular type? AB4. AB4 means what it is, man? All are here. I will explain here. Clear for this? If AB4 is there, you know, and here A and B, and here also B, here also B, and here also B. What is the shape, Maria? Tetrahedral shape. If tetrahedral shape, what will be the bond angle here? 109 degree, 28 minutes, or simply you can say 109.5 degree. Clear? But instead of here, instead of one bond pair, here which one is coming? Lone pair is coming. When lone pair comes, tetrahedral shape distorted. Clear? So how it will be used? And due to here also the same reason. Clear? Previous there is no bond pair, that tetragonal 109.5 degree. But here which one is there? Instead of one bond pair, here what is there? One lone pair. Then what it is, Maya? It is a lone pair, and these are which one? Bond pairs. And here there will be a repulsions here. There will be which one? Repulsions. And to avoid these repulsions, these 2 bond pairs here, this is also acquires the pair. So these 2 bonds will come close to each other. Why they come close to each other? Because bond pair repulsions are somewhat less. So that's why when they come close also they experience the less repulsions compared to the lone pair and bond pair. So these 2 bond pairs will come close. When they are coming close, then automatically what will happen? Bond angle decreases. So that molecule will have the different shape compared to the tetrahedral, and what is that shape here is pyramidal shape. What is the shape of that molecule here? Pyramidal shape. So why it is acquires this pyramidal shape, the molecule? Because of lone pair bond pair repulsions are greater than bond pair repulsions. Same reason here. So the bond angle is reduced to, so here if you take any bond angle here, the bond angle here is 107 degree. Actually, what should be the bond angle here? 109.5 due to this lone pair, and that bond angle is reduced from 109.5 degrees to 107 degrees. And the molecule acquires which shape? Pyramidal shape. What is the reason for that? This is the reason. In the same way, if you take the AB2E2, 2 bond pairs and 2 lone pairs. Clear? What molecule is the example I have given? Clear? But here you see, if you see the bond angle here, 104.5 degree. Clear? So in this case, see what happened. Actually, if you know all are bond pairs, clear? And the structure would have been a, what it is here, tetrahedral if all were, what is here, bond pairs. But here how many lone pairs are there? 2 lone pairs. Then automatically the shape will change. What is the shape here? Bend shape, or you can say angular shape, or you can say V shape, whatever it may be. Angular shape, or what is here? V shape, and what is V shape, all you can use it. Whatever it may be. Here also angular shape or V shape you can write it. Clear? But what happened here? Why that angle here? Once if it is all are bond pairs, then what should be the angle here? Tetrahedral angle how much? This should have been tetrahedral, so that's why the angle should be what is 109. But what is the angle here? 104.5 degree. Got my point here? So what is the reason there? Instead of here, previous only 1 lone pair is there. Now here how many lone pairs are there? 2 lone pairs are there. This is, you see, simple. So if it is a central atom, and if you all are, you know, bond pairs, then this is the shape. Which is the shape here? Tetrahedral. What is the angle? 109.5 degree. But instead of 2 bond pairs, how many lone pairs are there here? 2 lone pairs. That is all I have written here. This is 1 lone pair. This is 1 lone pair. Clear? So what happened here? You see in this case. In this case, lone pair is there. Here lone pair is there. Here which one is there? Bond pair. And this is bond pair. Clear? Lone pair repulsions are greater than the lone pair and bond pair. So that's why there will be a very large repulsion, more extent of repulsion between the lone pair and lone pair. And to avoid this repulsion, these two lone pairs will move away from each other. Away from each other means they are coming close to which one? Bond pair. They are coming close to bond pair. Then what will happen here? You will get here lone pair and bond pair repulsions. Here also what will get? They are coming close. Then lone pair and bond pair repulsions. So lone pair bond pair repulsions are greater than the bond pair and bond pair. So that's why these two bonds, to avoid these repulsions, they move close to each other. Then what will happen? The bond angle decreases from 109.5 degrees to 104.5 degrees. That is the result. See, simple. Here, in this case, I will write very clearly. Clear? So here, there is a hydrogen. Here, which one is there? There is a lone pair. And here there is a lone pair. These are lone pair. There will be repulsions. To avoid these repulsions, and these lone pair come close to, they are moved away from each other. They are moving away from each other means they are coming close to what it is now. This is bond pair. And here also what it is now. This is bond pair. They are coming close to bond pair. Then what repulsions you will experience here? And lone pair and bond pair repulsions will experience this molecule. Here also lone pair and bond pair repulsions experience. So that's why lone pair bond pair repulsions are greater than bond pair. So that's why these repulsions are less. So that's why. And these molecules, these two bonds come close to each other. When they are coming close to each other, and the angle 109.5 angle will decreases to 104.5. Then the molecule acquires which shape? Bend shape. This is the reason, because lone pair repulsions are more than lone pair bond pair repulsions, which is more than bond pair repulsion. So angle is reduced to what is here 104.5 degree from 109.5 degree, and these are what is here AB to EB. And next also I will write. Okay, the next one is another molecular type AB4E. So how many bond pairs here? 4 bond pairs, and here 1 lone pair. See now, here very important. Yeah. So you know that when there are 4 bond pairs and 1 lone pair, what is the shape of that molecule here? Seesaw shape. So previous I mentioned SEA, that is please correct that one. It is not a C. It is SEE, seesaw shape. Clear? So in this one we can write in 2 different ways. Clear? So we know whenever there is a trigonal, if there are all are bond pairs, then what is the shape of the molecule? Trigonal bipyramidal. What is the trigonal bipyramidal? I will write here. What is the trigonal bipyramid here? There will be one triangle, clear? And there is a pyramid. So this is A, and suppose you know all these are BB, and this is if all are bond pairs, and this is the shape of the trigonal bipyramidal. But here one lone pair is there. So where we have to keep that lone pair? And in this trigonal bipyramidal, and the bonds in the triangle, you know, it is these 3 bonds we will call as equatorial bonds. Which bonds are here? These are equatorial bonds. And here these 3 are equatorial bonds. And you know these are pyramid like are there, and these we will call as axial bonds. These we will call as what is here? Axial bonds. So how many equatorial bonds we have in the trigonal bipyramidal? 3 equatorial and 2 axial bonds. Now we have one lone pair, and where we have to keep that lone pair? Inside the triangle or on the at the equatorial position or at the axial position? That is important. Clear? So how it will be made? You see now. I have written here 2 structures. One is first structure. I have kept here. See, what is the example for this? The example for this is SF4. I have already given. What is the example for SF4? And I have taken SF4 as an example. So now you see. And in the first case, I kept here lone pair at axial position. In the second case, I kept the lone pair at the equatorial position. Which one you have to prefer? Clear? So that is, if you see in this case, if I take here lone pair is in axial position, clear? And this lone pair make a 90 degrees with the three equatorial points I already said. And this is a triangle. Triangle is there on my palm hand. Clear? This is the triangle just assume. And here there is a one lone pair, and if it is there, another one bond is there. Here one lone pair is there. This one lone pair making here three bonds are there. Just assume these are three bonds. And here, what is my lone pair? The lone pair is making 90 angle with the three equatorial points. What my point here? So that's why. And the lone pair and bond pair separation how much? 90 degree. What my point? If I keep in this case, clear? Now, how many lone pair bond pair repulsions can I get here? 1, 2, and 3. 3 lone pair bond pair repulsions observed in this stage. Clear? Well, if I keep the lone pair on axial position. Next, second one. And in this case, I kept here lone pair at the equatorial position. If I kept here equatorial position and this lone pair and making here 90 angle, here 90 angle. But here what is 120 lone pair to bond pair, lone pair to bond pair, which are present inside that triangle is 120. 120 means more separation. So that's why there is no repulsions between the lone pair and bond pair. Because 120 degree separation means lone pair and bond pairs are away from each other. They will not experience any repulsions. But here this lone pair and here two axial bonds are there, bond pairs are there, and they make here this lone pair make 90 degree angle with both the axial bond pairs. So here they experience the two types of means two repulsions. Means one is lone pair bond pair, another one is lone pair bond pair. But here how many repulsions are there? 3 bond pair repulsions. But here 2 lone pair bond pair repulsions. As the repulsions increases, stability, energy increases, stability of the molecule decreases. So in case of A, and this structure having 3 types of the, you see, in the structure A, we have 3 types of 3 lone pair bond pairs repulsions at 90 degree. But in B, lone pair is an equatorial position and there are 2 bond pair lone pair repulsions, and hence B is more stable. Whenever there you have one lone pair in the trigonal bipyramidal structure, you have to put the lone pair at the equatorial position, not at the axial position. That is very important. In the competitive examination, they will give this type of questions. Trigonal bipyramidal, they will put one here and one here and one here. You can put this lone pair at any equatorial position. So which one is the correct structure they will ask. So important this is clear. So which one is the correct one and this is the correct one. B. Why? Because here repulsions are less and here repulsions will be more. If more the repulsion, more will be the energy, less will be the stability. That is the case. Now, third one, last one. AB3E. Clear? Here how many bond pairs? 3 bond pairs. And how many lone pairs? 2 lone pairs. What should be the structure? Same only. Here also 3, 4 plus 1, 5 bond pairs. Here 4 plus 1, 5 pair of electrons. And here also 3 plus 2, 5 pair of electrons. But in this case, 3 bond pairs and 2 lone pairs. Now 3 possibilities we have. Clear? Same line. So how many possibilities here? First I will keep the 2 lone pairs at the equatorial positions, and another one is one I will keep at the equatorial position and another one I will keep at the axial position, and second one both I will keep at the axial positions only. So where I have to keep the lone pairs? Lone pairs should be kept at equatorial and means equatorial positions. Why? Because in this case, see here, you will have this is 90 degree and here also what is 90 degree. Clear? So here lone pair bond pair, lone pair bond pair. But here you see this lone pair, it is 90 degree and here also 90 degree. This is also lone pair bond pair repulsion. This is also lone pair bond pair. Means if it is at axial position, how many it is axial position? How many lone pair bond pair repulsions will be there? 3. So one is at axial position means it will have the 3 lone pair and bond pair, and plus this is also making, and this is also one lone pair repulsion. Here not repulsion, and here lone pair bond pair repulsion. Total how many? 4. But here in this case how many repulsions are there? 4 lone pair and bond pair repulsions. You got my point here? Whenever lone pair is at axial position, how many lone pair bond pair repulsions will be observed? 3. And here one is at equatorial. Equatorial means this is 90 degree with the axial bond pair. So it will also make a 1 repulsion. So total how many repulsions are there? 4 repulsions are there. And if you see in this one axial make a 3 bond pair repulsions, 2 axials are there. Totally 6 lone pair bond pair repulsions are there. But if you take in this case, how many bond pair lone pair repulsions are there? Lone pair bond pair repulsions are there. 2 only. Got my point here? So that's why here 2 lone pair bond pair repulsions, but here 4 and here 6. So which one is the most stable form? Less means more the bond repulsions, more will be the energy and less will be the stability. So this is the correct one. Here is the correct one. Clear? So whenever there are 2 lone pairs are there, where you have to keep those 2 lone pairs, and you have to place at the equatorial position, not at the axial position, or even not one is at the equatorial and another one is at the axial position. Got my point? Very important this is. So that is all I have written. What is the reason for that? So in a lone pair at equatorial position, so there are less lone pair repulsions compared to the other which the lone pairs are axial position. So actual structure is which one is the most stable one? This is the most stable. And due to this lone pair repulsions, lone pair bond pair repulsions and lone pair repulsions, and the molecule should have the what is the actual structure here, trigonal bipyramidal, but what the shape of the molecule is? The shape of the molecule is T shape, and these are the reasons why and molecules and changes from the regular shape to another shape when lone pairs are present on the central line. So next one, if we combine all, here I have mentioned sometimes only bond pairs are there, then what is the shape when bond pairs and also lone pairs are there in the molecule? So what is the shape we have discussed? So I will write all together combined, then you will get the clarity. Very important this table. Clear? So previous what I have discussed is that one only. I am writing in a simpler manner. Clear? So just assume number of electron pairs 3. Clear? So what it is here? Both lone pairs and bond pairs. Here what it is here? Bond pairs plus what it is here? Lone pairs. This is clear. Means it can be bond pairs or lone pairs, or sometimes only bond pairs. Clear? First I will write here 2. Number of electron pairs 2. Clear? Number of electron pairs are 2 and number of bond pairs 2. There is no lone pair. What is the shape of the molecule? The shape of the molecule is linear. Always remember, when 2 bond pairs and there is no lone pair, and then the shape of molecule is 2. Clear? So this is all. And the next one. If there are 3 pairs of electrons, in that one all 3 are bond pairs and there is no lone pair. So what is the shape of the molecule? You already know what it is. Trigonal planar. Trigonal planar molecule. Clear? And if suppose in 3 electrons 2 are bond pairs and 1 is lone pair. What is it here? 2 bond pairs and 1 lone pair. 2 bond pairs and 1 lone pair. What is the shape here? The shape of the molecule is a bend shape. The shape of the molecule is which one here? The shape of the molecule is bend shape. This is also we have discussed. A, B, 2, E in this way. Clear? So this is about the 3 pair of electrons. Clear? Next one. If there are 4, then what it is now? If 4 are bond pairs and there is 0 lone pair, then what is the shape of the molecule here? Tetrahedral. Tetrahedral shape. What is the shape of the molecule? Tetrahedral. And another chance here. 4 bond pairs are there, and second one total 3 plus 1 4. 3 bond pairs, 1 lone pair. 3 bond pair and 1 lone pair. What is the shape of the molecule? Pyramidal shape. What is the shape of the molecule? Pyramidal shape. And another one I can write here. 2 bond pairs and 2 lone pairs. 2 plus 2. Total how many pairs? 4 pairs are there. Then 2 bond pairs and 2 lone pairs. What is the shape of the molecule? Bend shape, or V shape, or you can say angular shape. Clear? So this is about what it is. If there are totally 4, chances I am writing. And if it is 5, then what it is over here? And there is only bond pairs. Then what is the shape of the molecule? Trigonal. Trigonal. What is over here? Bipyramidal. Trigonal bipyramidal shape. Clear now? If it is 4 comma 1, 4 bond pairs and 1 lone pair, total 4 plus 1, how much now? Total pair of electrons 5. But in that one, 4 bond pairs and 1 lone pair. Then what is the shape of the molecule? We have seen seesaw shape. What is the shape of the molecule? Seesaw shape. Another one is there. And then 3 bond pairs and 2 lone pairs. Clear? Then what is the shape of the molecule? The 3 and 3 means just now only we have discussed. Shape of the molecule is definitely shape. And reverse 2 bond pairs and 3 lane pairs. Clear? Remember one point here. In this case, 2 bond pairs, at least how many bonds should be there? At least means only 1 bond is there. It is a, we cannot say this is a simple molecule. And to say the shape, it should have 2 or more than 2 bonds. Here 2 bonds are there, and here what is one? Lone pairs are more. If bond pairs are greater than lone pairs are greater than bond pair, always the shape of the molecule is linear. Shape of the molecule is what is linear. So that is it. Next 1 and 4 we cannot write. Why? It cannot exist. Here, 1 bond means simple molecule we will say. Clear? Monoatomic molecule. That is clear. This is about 5. In the same way, I am writing here. Clear? There are in the same way, what I will write here 5 vowel. Next what is 1? 6. 6 means only 6 bond pairs, there are no lone pairs. What is the shape means? Octahedral. What is the shape of the molecule? Octahedral. And another chance 5 and 1. Here also total how much? 6. 5 bond pairs and 1 lone pair. What is the shape? Square pyramidal. Square pyramidal. I have written all these shapes, so that's why just I am writing here. So next one is what? 4 comma 4 bond pairs and 2 lone pairs. 4 bond pairs and 2 lone pairs means simply it is a square planar. What is the shape of the molecule here? Square planar. This is about the 6. Last one is 7 and 10. 7 means only 7 and 0. So this is pentagonal bipyramidal. Pentagonal bipyramidal shape. Clear what this is? And last here 6 comma 1 is there. Then and distorted octahedral. Distorted octahedral. Clear? So these are what is here. And if dot means how many bond pairs are there, how many lone pairs are there, and that we have to. Example, don't bother about that example. Why? Because later we will discuss by taking the one example, we can simply say one molecule is there, and we can simply say how many bond pairs are there and how many lone pairs. We can calculate that. That we will discuss later. Yeah. So this is about the what it is here. So number of what it is, means shapes of the molecules, and when different number of bond pairs and lone pairs are present on the what is central center. So we have completed now VSEPR theory. Clear? So I already previously mentioned, and this theory is mainly to predict or to explain the shapes of the molecule. Clear? So now it has also some limitations, like Lewis puzzle limitations. I have already mentioned limitations of Lewis concept. Clear? So first limitation of Lewis concept, what it is, it does not explain the shape of the molecule, and that limitation is overcome by which one here? VSEPR theory. Clear? And the second limitation for the Lewis concept is, and it does not explain releasing of energy during the formation of covalent bond. Clear? And this theory also, it does not explain what it is here, releasing of energy during the formation of covalent bond. It just it has given only the explanation for the shapes of the molecule. Clear? So how much energy is released during the bond formation, and it also does not explain. This is also another one limitation, and that I have already covered there, so I have not written here. Another one is, and limitations, mainly 2 limitations are there, and it has limited application. Means it has given shapes for the some molecules but not all. Clear? So that is one of the limitation. And another one is it has given explanation based upon the directions of electron pairs. Clear? Electron pairs direction, but it is not seems to very clear. So does not seems very rational. So these two are the what it is here main limitations of VSEPR theory, and also it does not explain the releasing of energy during the formation of covalent bond between the two atoms. Clear? And so again, to overcome these limitations, another two theories have been introduced, and one is valence bond theory and another one is molecular orbital theory. Clear? And first we will discuss valence bond theory, and after that we will go for the molecular orbital theory. So I said first only four theories we have, and first theory means Lewis and Quasar theory concept we have completed, and VSEPR theory also we have completed. Now third one we have to discuss here what it is here VBD theory. What is the VBD theory here? And valence bond. Clear what it is here? Valence bond theory. Put the next one is valence bond theory. Simply this can be called as VBD. Clear? Clear? And to overcome the limitations of VSEPR theory, and mainly two theories have been introduced. Clear? And first one is valence bond theory and second one is molecular. That we will discuss later. Clear? And in this case, and this theory mainly this is introduced. This theory was introduced by two scientists. One is Hitler and London. Clear? So these are the two scientists and then introduced by this theory. Clear? And introduced this theory. And the next one is developed by this theory was developed by another two scientists. One is Pauling and another one is clear? So Pauling and Slater. Another scientist name is Slater. Clear? So this is, and this theory was introduced by scientists for Hitler, London, and developed by Pauling and Slater. Clear? And what is this theory and how it is based on how what is the information and all we will discuss. This theory mainly based upon some information. What is that one is electronic configuration of the atoms, and the second one is atomic orbital, knowledge of atomic orbital, overlapping of atomic orbital, hybridization of atomic orbital, and the next one is principles of variation and superposition. That we will discuss one by one. Clear? So first of all, you write here valence bond theory based on the following information. Clear? VBT is based on following information. So what is the following information? Means write the first one here. First one, electronic configuration of elements. What is the first one here? Electronic configuration of elements. Then we will discuss all these points one by one. Clear? So first of all, I will write what are those points. And second one is knowledge on atomic orbital. Knowledge on which orbital? Atomic orbitals. And the third one is overlapping of atomic. What is overlapping? What are atomic orbitals? How we will discuss overlapping of atomic orbitals. And the fourth one is hybridization. Hybridization of atomic atom. And last one is principles of variation and superposition. Variation and what is here? Variation and superposition. So these are the five. This valency bond theory is based upon following these five informations. What is the first one? Electronic configuration, atomic orbital, and the next one overlapping of atomic orbital, hybridization of atomic orbital, variation and superposition. Clear? And first we will discuss and valence bond theory in terms of energy consideration. In terms of what it is here, energy consideration. Put the heading. So first I will explain all together here. We just write all this, and finally after explaining all the things and VBT in terms of energy and VBT in terms of and overlapping, orbital overlapping. Clear? Then I will after discussing all these things and finally I will give the main postulates of VBT. Clear, my guys? So right here. VBT in terms of energy consideration. VBT in terms of energy consideration. Energy consideration. Clear? So this theory it explained. Clear? So I already mentioned one is the main limitation of the Lewis concept. What is the Lewis concept main limitation? One is the shape, that is overcome by the BSEPR theory, but second limitation is there. What is that one? Energy released during the formation of covalent bond between the atoms. Not doesn't explain that Lewis. Clear? So that is explained by VBT theory. That is only here. VBT in terms of energy. Clear? And here to explain this, I will take the simple example. So what is that example is? I will take the two hydrogen. Means hydrogen molecule I will take. What is the example I will take here? Hydrogen molecule. So hydrogen molecule means how it will be formed. So there will be one hydrogen atom and there is another hydrogen atom. Clear? So now I will write here. This is nucleus. And the nucleus, this is hydrogen atom A and this is hydrogen atom B. And the nucleus hydrogen atom is Na and the nucleus of hydrogen atom is another one is Mb. The electron of hydrogen is one electron we have, so Ea and here. Now, so what it has to form? It has to combine and to give what is one. It's two molecule actually. So what happened? These are atoms are there. When atoms they are coming close to each other. When they come close to each other, and then what will happen? Bond formation takes place. Clear? But here, whenever and atoms are approaching to each other to form a chemical bond, and there and new attraction forces and repulsion forces come to the operation. Clear? So when molecules are coming close, means one hydrogen atom it has to come and to form a H2 molecule, and while they are approaching very close to each other, and there we will observe some attractive forces and some repulsive forces. Clear? What are those attractive forces? First I will write here attractive forces. Attractive forces. What are the attractive forces? I will write here. Clear? What are the attractive forces here? Nucleus. Here Na means nucleus. Here Na means what? Here electron is there. And here also hydrogen atom. Nucleus here, electron, one electron will be there. There will be attractions between the nucleus and electron. So this is Na and Ea attraction. This is one attraction. Another one is what is nucleus of one atom and its one electron. That is what it is. Second one is nucleus of one atom with its one electron, that is EB attractions. One nucleus is a positive charge, electron is a which charge? One negative charge. Positive and negative there will be a attraction. So, and nucleus of one atom and its one electron, that is the attractive force. and the nucleus of another atom and its own electron. That is another attractive force. And what is the third one? What is the third one? What another one is, you know, attractions of nuclei of one atom and the electron of other atom. It is a positive charge, and here electron is a which charge? Negative charge, and positive, and because they are coming close, you know, they are coming close. This is positive, and here there will be a electron, and it is also coming here electron. It is what is positive. Then positive and negative attractions will be there, isn't it? That is what. So here another attraction force is Na and Eb. Clear? This is. And fourth one, what it is? Nb and Ea. Nucleus of this atom and electron of this atom. These are the repulsive forces. Clear? So, sorry, attractive forces. And next one is what it is here. Repulsive forces also existed. Repulsive forces. What are the repulsive forces, Maya? See the repulsive forces. What are the repulsive forces you can observe? Here, repulsions. Repulsions means what is one? Positive charge. Repulsions. Same charge. Repel each other. So what is the repulsions one? Repulsions takes place due to the nucleus of one atom and the nucleus of another atom. That is one. And what is the second one? And the second one is electron of one atom and the electron of another atom. Both are having same charge. There will be a repulsions. So these are when and bond formation takes place. Means when the two atoms are approaching together to form a bond. And here attractive forces and repulsive forces are come into the operations. And here the attractive forces and here repulsive forces. You know that attractive forces are tend to bring the molecules together, but repulsive forces tend to and push the molecules apart. Clear here? So in this case, actually, experimentally it is observed that in case of hydrogen, it is found that attractive forces are greater than the repulsive forces. Clear? Greater than the what it is here? Repulsive forces. And when attractive forces are greater than the repulsive forces, and then what will happen? Automatically the potential energy decreases. Energy what will happen? Decreases. Isn't it? Attractions means energy decreases. Repulsions means energy increases. So in this case, in case of hydrogen molecules, what will happen on here? Attractive forces greater than what it is what here? Repulsive. So that's why what will happen here? Potential energy decreases. What will happen over here? Potential energy decreases. Clear? So when they are coming close, clear? What will happen at a certain stage? The attractive forces are equal to the repulsive forces. Clear? First of all, just assume. I will draw one diagram, then you can easily understand. One hydrogen and one hydrogen. They are coming close to each other. And when they are coming close to each other, then first of all, which forces will operate here? Attractive forces. And if they are coming very close to each other, then what will happen? Repulsive forces, because they are coming very close, positive and positive repulsion will be there. That is. But at some point, there exactly, you know, attractive forces are equal to repulsive forces, and there the system has minimum energy and their bond formation takes place. Clear? That bond we will call as a formation of which bond by here? Covalent bond. Clear? So I will write here. At some stage, at one stage, clear? At one stage, clear? What will happen? Attractive forces, attractive forces are equal to repulsive forces. Clear? So there what will happen? Their molecule has minimum energy. Their molecule has what is here? Minimum energy and bond formation. Minimum energy and most stable. Minimum energy means what is most stable and the molecule. So for the first I will write here minimum energy and form bond between what is this here, two atoms, between two atoms. So that's why, and the molecule is what? Less energy, so that's why the molecule is a more stable. Clear? And this can be explained diagrammatically. So I will draw here diagram so you can easily understand. First of all, I will write here these forces, attractive forces and repulsive forces. First I will draw here, there is a, this is hydrogen atom A, clear? So this one positive charge is there, and another one, this is another hydrogen atom, this is a nucleus. This is what is my nucleus. So it is having one electron, this is also having one electron, which one might is a negative charge, and this is also having one electron. This is just assume nucleus Na, and this is what is my nucleus Nb, and here the electron A, and this is electron B. This electron is belongs to this atom, this electron is belongs to this atom. Clear? So already you know that if electron is present, hydrogen atom means you know already nucleus is there, one electron, there will be some attractive forces, and this is attractive forces, bold attractive forces. Already you see, well, this is nucleus and positive charge. This is one electron, this is one hydrogen atom. So this is nucleus and electron. There will be a attractive forces. That is only bold attractive forces I am saying here. Here also there is a attractive forces. That is what I have written. Na, Ea, Nb, Eb. These two are bold already in the hydrogen atom, and these attractive forces are existing. These are attractive forces. Both are attractive each other. What are the new one? This is new one. When bond formation takes place, and this is the new one. Nucleus of one atom, electron of another atom. This is new attractions, and here also this is new attractions. Clear? Electron of nucleus of another atom, electron of A atom. So this is, and two old attractive forces and new attractive forces. Total how many forces are there? 4. Clear? Repulsive forces. What is the repulsive forces? How I can write here? This is repulsive forces. And here there is a positive and there is a positive. This is nucleus of A atom and the nucleus of B hydrogen atom, and here electron of A, and this is electron of B. So these two, when they are coming close, they repel each other. This is the repulsive forces, they repel each other, and here also they repel each other, because when they are coming close, electron repulsions will be there, nucleus repulsion will be there. Okay? So these are repulsions. Now here how this potential energy decreases and how the potential energy minimum, and then also I will show here diagrammatically. Clear? So now see here in this case what happens. Clear? So I will write here potential energy. Clear? This is what it is here. Potential energy. Clear? So this is 0. Above is positive values and below is negative values. Clear? So this is the 0. Now I am talking about hydrogens. Clear? And two hydrogens are, they are just assumed at initially they are at infinite distance. A one atom, B one atom. They are at infinite distance. Then what will happen? When they have at infinite distance, you know, atoms will have, they are in form of atoms. I already mentioned atoms in the form of gas. So that's why they will have very high energy. Clear? When they are coming close, what will happen? Attractive forces operate. Then attractive forces operate. Then what will happen? Energy decreases. That is okay. At somewhere they are at very high energy, and when they are coming close, the energy is decreases. Energy is what is not decreases. Got my point here? When they are coming close, the energy is decreases, and somewhere it minimum, and again it is increases. Let us see this diagram once. So what happened here? You see, and first of all, they are. This is the minimum. Then here. Internuclear distance. On the x-axis we will take the internuclear distance. Clear? See now, what happened in this case? First of all, two hydrogen atoms. This is one hydrogen atom and this is one hydrogen atom. They are approaching each other. They are what is known here? Approaching each other at this point. They are approaching each other. When they are approaching each other, just what happened here? Energy is decreasing. Right here, they are approaching each other, one hydrogen and one hydrogen. This is the stage. When they are coming very close, attractive forces operated. Attractive forces are there, then energy slightly decreases. Clear? So keep on decreasing their energy. Clear? And now some point means here when they are coming close and make one bond here. This is clear? So they will come because attractive forces are there, they are coming close and attractive forces are there, and at some point of time, if they come very close to each other, then what will happen, Mahia? Then already attractive forces are also operated and repulsive forces also there. What is the repulsive forces, Ma? Here nucleus is positive and this is also what is positive, and they are coming up to here. Okay, no problem, attractions. If it is coming very close to this, then positive repulsions will operate. Got my point, Mahia? So that's why, and up to here what will happen? Energy decreases because attractive forces. At this point, clear? So what happened here? Attractive forces are is equal to repulsive forces. Means their repulsion starts. Why? Because they are coming very close to each other. Got my point? Where the repulsion starts and there, what it is here? Attractive forces are equal to repulsive forces and their bond formation takes place. If the molecule again coming very close to each other, see, very small, but here very close, then what will happen, man? And repulsive forces dominates the attractive forces. Then what will happen, man? Repulsive forces dominates, then repulsive forces dominates energy. This is concept. Clear, man? So this is at this point. Clear, man? So like this. This is just they are means at this point repulsive forces and attractive forces are what is here balanced with each other. Clear? And this is we will call as what it is here at this point repulsive attractive forces are is equal to what is here repulsive forces. So minimum energy. Clear? System is acquired what is minimum energy. There bond formation takes place at this point. So what happened here? Bond formation takes place. Bond formation takes place. Clear? And this is energy. You see, this is energy from here to here. How much energy is here decreasing? So that energy we will call as a bond enthalpy. Bond enthalpy. So during this bond formation, this much of energy is released from here to here. This is 0 and somewhere here negative. That much of energy is formed. And that energy will be called as a bond enthalpy. And now, and this is length is there from here to here. This we will call as a what is here bond length. Bond length of which one? Hydrogen atom. That is exactly 74 picometer. And means what it is? They can come very close up to how much distance? 74 picometers. If coming very close, means 70 picometer comes, bond formation will not take place. Why? Because up to the 74 picometers, attractive forces are equal to repulsive forces. Got my point? If it is less than 74, repulsive forces dominates, then energy increases, then the bond formation will not take place. So what is the minimum distance here? That is the bond length. And here, this is what we will call here bond length between the two hydrogen atoms. And here, this is minimum energy. Clear? So this is what we will call minimum energy. Got my point here? Two atoms are there, they are away from each other, and when they are coming close, attractive forces operate, attractive forces increases, and when attractive forces operate, then automatically what will happen? Energy decreases and keep on decreasing when they are coming close because attractive forces are keep on increasing at some point of time. at stage, what will happen? Repulsive forces also start operates. Why? Because when they are coming very close, positive, repulsion also starts. So that's why here starts. Means at this point, attractive forces are equal to repulsive forces. At that stage, bond formation takes place. Clear? And that energy will be called as a bond enthalpy, and that distance will be called as a bond length. If you keep again very close, then the repulsive forces dominates, and here attractive forces. Which forces were here? Attractive forces dominates. Attractive forces are more, and in this case, what it is? Repulsive forces. Repulsive forces dominates. Repulsive forces dominates here. Dominates. Clear? Repulsive forces dominates. Here, which forces dominates? Dominates. Attractive forces dominates. But at this point, both are same. There only one formation takes place. And this is, and how much energy is released. That Lewis, Lewis concept failed to explain how much energy is released when during the formation, during the bond formation. Means here, and hydrogen one atom. This is what it is, hydrogen gas atom. This is gas. Then what will happen? H2 molecule will be formed, and during this, energy will be released. That is 435.8 kilojoule per. What is here? Kilojoule per mole of energy. Means negative energy is released. To break hydrogen molecule into hydrogen and hydrogen also, how much energy required? 435.8 kilojoule per mole. Clear? So how much energy is released during the formation? That much energy required to break that bond and to convert it into the atoms. Clear? So this is about the and VBT. What it is in terms of energy considered.